So let's look at a few of them though, so you can see how the properties work. Now, you should have seen some of this stuff in Algebra 1. Like this says product of powers. A to the m times a to the n equals a to the m plus n. They're trying to show you the rule. And I think you've seen that before. Like when you've had, just an example, like if you had 2 to the 5th power times 2 to the 8th power, they're trying to show you the rule. What would the answer be if it was 2 to the 5th times 2 to the 8th? It's trying to show you the rule is add. When you multiply, you're supposed to add the exponents. So if I add 8 and 5 together, what do I get? Should get like 2 to the 13th power. Oh yeah, did I miss you somehow? Did you get one, Victor? You got one? Okay. Okay, so yeah, 2 to the 5th, 2 to the 8th, C is like 2 to the 13th. So it's showing you the rule on here. This whole chart is just full of definitions of how to do things. Now it's a little harder in Algebra 2 because you have stuff with like fractions. Here's the same question, but it has 5 to the 1/2 power times 5 to the 3/2 power. It's showing you you're supposed to add that up. 1/2 plus 3/2. That would be 4 over 2, 4/2, which would be 2, and then the answer is 25. So you have to know how to add these fractions up. You can use calculators for assistance though. See, that's 1/2 plus 3/2. That's the same as 4 over 2. 4 over 2 is just 2, so then they have 5 squared and they got 25. So what makes this tricky is all the fractions. It's the same rules you learned in Algebra 1, but now you have fraction exponents. But you do the rules the same. We went over negative exponent last time. If you have like 36 to the negative 1/2 power, you put it in a fraction. So it turns into 1 over 36 to the 1/2 power. And 1/2 power is like a square root. The square root of 36 is 6. Yeah, so the 36 to the 1/2 power, that's the same as square root of 36. Because the 2 would go in front, it'd be a square root. And it came out to 6, 1/6. Another one that a lot of students forget is 0 power. Anything to the 0 power equals 1. That's something you should kind of memorize, 0 exponent. Anything to the 0 power equals 1. When you have fractions, you need to subtract the exponents. They have a rule for that. So they're showing you all the rules on this page and have examples. So here's one quotient. A quotient's like dividing. When you're dividing, you subtract the exponents. So they did that here, 5/2 minus 1/2. That'd be 4/2, which would be 2. 4 squared is 16. So look over all these rules, all these properties. And then we'll start using them so you'll see how they work. We'll go down and do an example and we'll be like, what rule does it, which one is it? Which one of these does it follow? And there's properties for radicals too, for square roots. Radicals are these roots we've been working on. There's a product property of radicals and a quotient property of radicals. And they show you here, if you have something in a radical, you can like separate it. It kind of shows you how you can like split it apart, or vice versa, or you can put it back together. So this has the third root of 4 times the third root of 2. They're trying to show you could just times those, since they're both in like a third root, you could just times 4 times 2 and you get 8. So it's the third root of 8. See how they just put it together? It's kind of weird. The quotient property shows that you can divide the numbers that are in the fraction inside the box if they're the same power outside. These are both like 4th power, so they're showing you could just make the whole thing 4th power of 162 over 2. And they divided 162 divided by 2, it's 81. Then they did the 4th root of 81 and got 3. So it's all about simplifying and using these rules. There's a bunch of rules to follow. So let's try a few on our own. I know it just takes a little studying over these charts and see how they work. So this has 2 to the 3/4 power times 2 to the 1/2 power. So if we look up above, this is a times problem. This is a product problem. Multiplication is called a product. This is the product of powers rule from up above. It's 2 to a power times 2 to another different power. You can add that up. You can take 3/4 plus 1/2. You can add their powers. That's how the product of powers work. You can add 3/4 plus 1/2. And you can use a calculator to help you out. 3/4 plus 1/2 is, well, you can change it to common denominator. Okay, so this has 3/4. If it's 1/2, how many fourths is that? Remember how you do common denominators? You times this by 2. You want to get a common denominator. So it'd be 2/4. Then you add it up, that'd be 5/4. 2 to the 5/4 power. And that's the same as 2. Well, it says simplify, so I guess that's it because it doesn't say solve it. So I would just leave it like that actually. Because that one's gonna not come out nice if I do 2 to that power, 2 to the 5/4 power. That won't come out nice. There'll be some decimal. So since it just said simplify, I can be done. It just said simplify it. It didn't say solve it and put the decimal. There's a difference between simplify and solve. Simplify means like get it worked out as much as you can and then just leave it. Because I know that's not gonna, that comes out to a decimal on my calculator. So I don't want it to put the decimal. I just wanted to work it out as much as I could. Simplify it, not solve. See, I didn't solve, no solving, no decimals. Work it out as much as you can. Okay, now this one, this has 3 on the top. Isn't that like 3 to the first power? And then this is 3 to the 1/4 power under it. This is a division problem. This is a quotient one. This is a quotient. Quotient's like dividing. So we gotta look up above and try to figure out how we're gonna do this one. This is a quotient of powers one. So you're supposed to do 1, that number 1, minus 1/4. You're supposed to figure out 1 minus 1/4. 1, can you make 1 into a fraction? Isn't that like 1 over 1? I need a common denominator, so it's actually like 4 over 4. 4 over 4 is the same as 1, right? 1 is the same as 4 over 4. I want to make a common denominator 4. So 4/4 minus 1/4. So I'm getting 3 to the 3/4 power, and then I'm done. Because it doesn't say solve again. I don't need to grab my calculator. It just said simplify. So that one's done. Okay, so it's just like simplifying these as much as you can using the rules. Okay, then we flip it over to the back. This has 20 to the 1/2 power and 5 to the 1/2 power. Well, a 1/2 power, 1/2 power is like a square root, you guys. 1/2 power is like, you remember how you could write it as a root? And they're both to the 1/2 power, so it's just like you could just do 20 divided by 5, since they both say 1/2 power. What is 20 divided by 5? That's 4, and then you do the 1/2 power on that. The 1/2 power is a square root. 1/2 power. So you got to know that 1/2 power equals square root. You guys got to know that 1/2 power is a square root. So what's the square root of 4? What is the square root of 4? You guys should know that. What's the square root of 4? Yeah, it's 2. And then the last step, it had the third power on the outside. So the last step is to do 2 to the third power. Let's see what that is. 2 to the third power. That's like 2 times 2 times 2. So that's 8. Now I'm done. So see, they both said the same power. So you could just divide 20 and 5. So that one's like the quotient property that's on the front. They're both in like a same power or same root, so you could just divide them. That one, see, that makes it easy. Okay, we're almost done. Last one over here. 5 to the 1/3 power. Okay, and then I got parentheses around this, and then I got 7 to the 1/4 power. Ooh, yikes! This one looks kind of scary. This one's like power of a product. I'm gonna write that down on the side. That might help. Power of a product. It's like the one on the front, the property that says power of a product. When you have a power on this outside, it's like you can kind of like distribute it in. It says 5 to the 1/3. You can take 1/3 times 3. You can like distribute that in. 1/3 times 3 is just 1. It's like 3 over 3, which is 1. If you just times 1/3 times 3. I'll write it. It's like 1/3 times 3. So it comes out to 5 to the first power. This actually makes it super easy. And then same thing here. It's 7, and you have to do like 1/4 times 3. That little power there. 1/4 times 3. That'd be 3/4. So that one's kind of weird, isn't it? Because the 5 and the 7 like didn't match up. So you actually can't do anything else with that. Like these aren't the same number. So you just have to leave it like 5 times 7 to the 3/4. Because this is with they're not the same base number, so you can't do anything else. That's it. That's simplified as much as you can. That's it on that one. I know that one's a weird one. You could only like go more if these were both like the same number, like if they were both 7s. You can't do anything else though, because it's not the same number. It's not the same big number. The base number's not the same. Okay, we're getting to the end. Okay, use the properties of radicals to simplify. Okay, this one's like the product property on the front with the radicals. And they're both, see how they're both to like the third root? They both have the same box thing around it. So you can actually just times 12 and 18 together. 12 times 18 would be in like the third root. You could actually times them together since they're both in a third root. So just kind of go with your gut, like, oh yeah, I think I can times those. You know, you can see they're the same. So that's 216. If you take 12 times 18, it's 216. And then you could actually finish this one up. You could finish this one up. The third root of 216, like 216 divides by 6, and that's 36, and 36 is 6 times 6. The third root of 216 is just 6, because you can see there's like 3 6s that make 216. It's in a third root, so it's just 6. Yep, because it's like 6 to the third power, and then it's in a third root. We talked about how those cancel, so it's just 6. Here's another property one. See how they both say fourth root on the outside? So you can literally just take 80 divided by 5 and put it like, see, like the fourth root. The whole thing's in a fourth root. It's kind of common sense. You can kind of tell, like, oh yeah, they're both have the same outside root thing. So you can just do 80 divided by 5. That's 16. So then figure out the fourth root of 16. You can do that on a calculator, the last step. The fourth root of 16. Like a number that goes into 16. 4 of them. Do you know what? Take a guess what it is? Yeah, 2. 2 times 2 times 2 times 2 makes 16. Yep, 4 of them. So hopefully you're kind of getting it. I know that